The title of the lesson, Grouping of Lamps. Vocabulary, series grouping, parallel grouping. The laws, law of addition of voltage in series grouping, law of uniqueness of current in series grouping, law of uniqueness of voltage in parallel grouping, law of addition of current in series grouping. Students should be able to state the laws of voltage and current in series and parallel groupings, apply the laws of voltage and current in series and parallel groupings, represent a series and parallel grouping of lamps in a circuit, describe the effect of a burnt out lamp on the functioning of other components in an electric circuit. So one Christmas night, while you were looking at the Christmas tree lights, one bulb suddenly makes a spark and goes out. Yet the other ones stayed on. So you asked yourself how this can be. The answer is actually because the bulbs are connected in parallel. I'm going to explain this idea when we get used to dealing with parallel groupings and series grouping, and we know how does the voltage and the current vary. So I'll be back to this idea when we are done with the main ones. So a grouping of lamps. For series grouping, the voltage is additive, the current is unique. For parallel grouping, the voltage is unique and the current is additive. I am going to prove this idea by using the FET simulation. As you can see, this is a circuit composed of a battery and two lamps connected in series. So I'm going to measure the voltage across the battery. It should be connected in parallel across the battery. It indicates, as you can see, 9 volt. So U battery is 9 volt. Now the voltage across the lamp is 4.5 volt. So U1 is 4.5 volt. Now the voltage across the second lamp, U2, is 4.5 volt. So U1 plus U2 is equal to U battery. Then the voltage in series grouping is additive. Now concerning the current. The ammeter is used to measure the current and it's connected in series. So first connected in series to the battery. I main or I of the battery is 0.45 ampere. Now I'll disconnect it from the battery and connect it in series directly. This is the conventional direction of current, and connect it directly to the first lamp U1. It indicated also 0.45 ampere. Now connected in series to the other lamp. Sorry, this is done by mistake here. So connecting it in series with the other lamp. Again, the ammeter is going to indicate 0.45 ampere. This means that the current is unique in series grouping. Now doing a direct application, or before this, let us state the laws, then do the application. So when I ask you to state the law, you have to use words to explain it. Statements of laws. Law of addition of voltage in series grouping. The voltage across the generator of a series circuit is the sum of voltages across each component. So the generator here is the battery. U battery equals U1 plus U2. Law of uniqueness of current in series grouping. The intensity of the current flowing through all the components in a series circuit is the same. So I main equals I1 equals I2. Direct application. Application 1. Series grouping. Indicate whether the two lamps are connected in series or in parallel, and Number 2, given the following: U battery 9 volts, U1 5 volts, I main 3 ampere. Calculate U2, determine I1 and I2. So this is series grouping because only one terminal of one lamp is connected to one terminal of the other. Now here in this case there is no need to justify because the action verb is indicate. 2. Calculate U2. U2 is the voltage across the second lamp. So U is the symbol of voltage and U2 is the voltage across the second lamp. U battery is 9 volts. U1 is 5 volts. So what is the relation between U1, U2 and U battery? By law of addition of voltage in series grouping, U battery equals U1 plus U2. 9 volt equal 5 volt plus U2. Bring 5 to the other side, it becomes minus 5 volt. Then U2 is equal to 4 volt. Now determine I1 and I2. Law of uniqueness of current in series grouping. You have to mention the law because the action verb is determined, so you need to justify. Law of uniqueness of current in series grouping. I main equals I1 equals I2. This is the rule. And you do the substitution, which is equal to 3 ampere according to the given. Now moving to the parallel connection. Now concerning the parallel grouping, we're going to do the same work. We're going to measure the voltage across each component and find the relation between them. Okay, then measure the current and also find the relation. So using the voltmeter, starting with the voltmeter, measuring the voltage across the battery, it is equal to 9 volt. Measuring the voltage across U1 is 9 volt. Measuring the voltage across U2 is also 9 volt. This means that the voltage in parallel grouping is unique. It's the same. For the ammeter, we are going to connect it in series with each lamp. So I battery or I main that's coming out of the battery is equal to 1.8 ampere. Now let's connect it in series with L1 in order to measure the current across L1. So I1, I is the symbol of current. I1 passing through the first lamp is 0.9 ampere. Now connecting the current in series with the other lamp. It's 0.9 ampere. So I main is 1.8, I1 0.9 and I2 0.9. This means that I main equals I1 plus I2. So in parallel grouping, the current is additive. Here are the laws, the statement of the laws. Law of uniqueness of voltage in parallel grouping, you have to memorize it. The voltage across the generator of a parallel grouping is equal to the voltage across each component for the circuit. So U main equals U1 equal U2, and by U main here I mean U of the battery, U of the main source of voltage. Law of addition of current in parallel grouping, the intensity of the main current is equal to the sum of the currents in the branches of a parallel grouping. So this is considered to be a branch and this is another branch. I main equals I1 plus I2. Now direct application. Application 2, indicate whether the two lamps are connected in series or in parallel. Again, indicate, no need to justify. This is parallel grouping. Given the following: U battery 9 volts, I1 3 ampere, I main 5 ampere, determine U2 and U1. So we know that in parallel grouping, law of uniqueness of voltage, U main equals U1 equals U2 equal 9 volts. While for part B, calculate I2, we have that by law of addition of current in parallel grouping, you have to mention the law and then write the rule, which is I battery equals I1 plus I2. Then do the substitutions. 5 ampere equal 3 ampere plus I2. Bring 3 to the other side, change its sign, it becomes minus 3 ampere, so 2 ampere equals to I2.